am Dr. J. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss the topic test of hypothesis for single proportion. In the previous sessions, we have completed two tests. First one, test of hypothesis for single mean. The formula is z equal to x bar minus mu by sigma by root n. And the second test of hypothesis for difference of means. The formula is x1 bar minus x2 bar by under root of sigma 1 square by n1 plus sigma 2 square by n2. In case the problem consists of only one sample, we can use test of hypothesis for single mean. In case if the problem consists of two samples, we can use test of hypothesis for difference of means. Now we are going to discuss test of hypothesis for single proportion. Before going to discuss about this test, first we have to learn what is proportion. What is mean by proportion? That is called sample proportion. Sample proportion. What is the meaning of sample proportion? I'll explain you with simple example. Suppose in a manufacturing company, out of 200 goods, total number of goods are 200. 18 were defective. 18 were defective. Then the sample proportion symbol, small p, which is 18 by 200. Here the sample proportion is defective, for defective. Sample proportion for defective. Similarly, in case if the same example within a different in a manufacturing company, out of 200 goods, 18 were good. 18 were good. In that case, the sample proportion also same, P, for good. For good goods, P equal to same 18 by 200. That means this is called exhaustive events by the total number of events, where exhaustive events denoted by small x and the total number of events we can denote by n. So the sample proportion is P equal to x by n, where x is the number of exhaustive events by the total number of events. Suppose if I take another example, in a classroom the total number of strength are 60. Out of 60, only the 5 students are excellent. What is sample proportion for excellent students, which is denoted by P equal to 5 by 60. Here this P is sample proportion for excellent students. For excellent students. And similarly, if I take another example with the same n equal to 60 in the classroom, where x is bad students in the classroom, 5 members. So now I want to find out the sample proportion for bad students, even though which is x by n, 5 by 60. This is the sample proportion for bad students. This is the same sample proportion for excellent students. Whatever the statement is given, the number of exhaustive events by the total number of events are known as sample proportion for the particular event. So that is the definition. In a random experiment, the total number of events are n. Total number of events are n. And the exhaustive events are small x. Whatever the exhaustive, either it may be success or failure. Either it may be good or defective. Either it may be excellent or bad. Whatever it is, exhaustive events. And the sample proportion is denoted by small p. Because it's a sample proportion, sample. That's why we can denote it with a small p. Generally, the population proportion we can denote it with capital P. Population proportion we can denote it with capital P. If this value is not given, we can take 1 by 2 or 0.5, which is fixed. In case in the problem, the capital P value is not given, we can take the population proportion is 0.5. So this is the definition of proportion or sample proportion. In any random experiment, the total number of events are n and the exhaustive, whatever the exhaustive events are small x, then the sample proportion small p is the number of exhaustive events by the total number of events. Now we are going to test of hypothesis for single proportion. This topic we discussed in the previous slide, proportion or sample proportion. Now we are going to do test of hypothesis for single proportion. The description of this test is a large sample of size n, is taken from the population, This sample proportion is small p and the population proportion is capital P. Sample proportion is small p and the population proportion is capital P. Then the test statistic in step 4, z equal to formula small p minus capital P by under root of capital P into capital Q by n, where this capital Q value we don't know. If you know capital P, we can find out capital Q value by using the formula 1 minus P. Here we are going to get one doubt. What is that doubt? Here we have only one sample. In the previous sessions, I told you that if you have only one large sample, we can use test of hypothesis for single mean. But here also same one sample. Why we are going to use the test of hypothesis for single proportion? A small difference between test of hypothesis for single mean and single proportion. There, in test of hypothesis for single mean, we are going to test the sample came from the population. The sample mean only we are testing. In null hypothesis, there we have tested mu equal to something. Here we are going to test capital P equal to something. Discussing about only the proportion, sample proportion. That proportion, what is proportion, we have discussed in the previous slide. In test of hypothesis for single mean, we discussed only the mean concept. Here we are going to discuss about proportion concept. That is the difference between test of hypothesis for single mean for large samples, similarly test of hypothesis for single proportion for large samples. Right? Now, here we have confidence interval for the single proportion is small p plus or minus 3 into under root of pq by n. This is the confidence interval for single proportion small p. Like we have discussed, confidence interval for single mean x bar is also. Now we'll discuss the problems on this topic. The description of the problem is, first we need to identify which test is suitable for the given problem. Right? A manufacturer claimed that at least 95% of the equipment which is supplied to a factory conformed to specification and examine. Conformed to specification. He is saying that the manufacturer is claiming that whatever the equipment is supplied, 95% of his equipment is in good position. An examination of sample 200, one sample we have chosen, that is 200 pairs of equipment, revealed that 18 were default, 18 were faulty. This statement is given. Out of 200 pairs, 18 were defective or faulty. What we are going to find, test is claimed at alpha 5% level of significance. According to the description of the problem, which test is suitable? Only one sample, sir, 200 sample size. Its mean is not given, but some statement is given. What is that statement? Out of 200 samples, 18 were faulty. Either which test is suitable for this problem? Test of hypothesis for single mean or test of hypothesis for single proportion? We can identify very easily. Small p proportion value is given, which is x by n. 18 were faulty out of 200. That's why this problem suitable for test of hypothesis for single proportion, not for single mean, because the statement of proportion is given in the problem. So all values 18 by 200, which is nothing but 0.09, and capital P is given 95% of his equipment is good position. That is the population proportion, capital P equal to 0.95. We'll discuss why we have taken P greater than 0.95 later. If P equal to 0.95, Q we can take 1 minus P, 0.05, alpha is 0.05. All values are given. Now the procedure of test of hypothesis, we are going to set up null hypothesis H naught. Whatever the statement he has given, we have to assume the statement is true. What statement he has given? At least 95%, P greater than 95%. At least 95% means P greater than 95%. Whatever the equipment he is supplying, which is in good position. But generally, instead of P greater than 95, we are going to set up P equal to 0.95 in null hypothesis. That's why we have chosen P equal to 0.95. But actual statement is P greater than 0.95 only. Instead of greater than, we have chosen equal to. But actual statement is P greater than 0.95. Now alternative hypothesis H1, we are going to set up against to null hypothesis. What is null hypothesis actually? P greater than 0.95. What is the against statement? P less than 0.95. That's why we have taken P less than 0.95. Less than means which type of test? Left-tailed test. Left-tailed test, because less than. If it is not equal to two-tailed test, if it is greater than right-tailed test, and if it is less than left-tailed test. And the step 3 level of significance, alpha equal to 0.05, z alpha value minus 1.645 at alpha equal to 0.05 for left-tailed test. This we can choose from Z alpha distribution table. Z alpha is minus 1.645 at alpha equal to 0.05. I'll show you this value from Z distribution table. Alpha 0.05, left tail test, Z alpha minus 1.645. This is Z distribution table. At alpha 0.05, Z alpha is minus 1.645 for left tail test. In case if the problem is two tail test, 1.96 if you take. But our problem is left tail test. That's why we have taken Z alpha equal to minus 1.645. That's why we have chosen Z alpha minus 1.645 at alpha equal to 0.05 for two tail test. The test statistic Z formula already we have discussed, small p minus capital P by under root of capital PQ by n. Small p 0.09, we calculated small p equal to x by n, 18 by 200, 0.09 minus capital P 0.95. This value I have taken for this purpose only. Actually the capital P is greater than 0.95, but generally we can set up in null hypothesis capital P equal to 0.95 by capital P 0.95 into capital Q, where capital Q is 1 minus P by n sample size. If we simplify, we are going to get Z equal to minus 55.8, minus 55.8, and mod Z equal to 55.8, and Z alpha in step 3 minus 1.645, minus 1.645. Now if you compare these two values, mod Z and Z alpha, in the conclusion mod Z is greater than Z alpha. That means we are going to reject the null hypothesis. What is null hypothesis? H naught P greater than 0.95 or 95%. That means we are rejecting this one. Rejecting this one means whatever the statement he passed, that is the wrong statement. That means he is claiming that 95% of equipment, at least 95% of equipment which he is supplying conform to the specification. That statement is wrong, we have done. So this is the procedure to test of hypothesis for single proportion problems. Now, going to second problem. A social worker believes that fewer than 25% couples in a certain area have ever used any form of birth control. This is a general statement. The social worker given that his belief is less than 25% of couples in the particular area have ever used any form of birth control. And in that particular area, a random sample of 120 couples were contacted. Out of them, 20 said they have used. This is the proportion statement. P equal to 20 by 120, which is 0.167. Test the belief of social worker. Test the belief of social worker at alpha equal to 0.05. According to the description of the problem, which test is suitable? Only one sample with size 120 and the mean is not given, but proportion is given. That's why we are going to use test of hypothesis for single proportion. And here capital P we have taken 0.25. Why we have taken 0.25? The general statement, population proportion, a social worker believes that less than 25, actually P less than 25%, 0.25, but generally we can take capital P is 0.25. If capital P is 0.25, capital Q equal to 1 minus P, 1 minus 0.25, 0.75. Same null hypothesis, we are going to set up null hypothesis H naught, P equal to 0.25. Actual statement is P less than 25% of couples ever used the birth control. But generally we can set up with P equal to 0.25. The against null hypothesis is alternative hypothesis. For less than, the against statement is greater than. That's why this is right-tailed test. Right-tailed test because greater than. And alpha is 0.05. Z alpha is 1.645 at alpha equal to 0.05 for right-tailed test. For right-tailed test. This is the Z alpha distribution table value for right-tailed test, as we have seen in the previous problem. Right. The test statistic formula Z equal to small p minus capital P by under root of p cube by n. All values we know that. Small p is 0.165, capital P is 0.25, capital P is 0.25, capital Q is 0.75 by sample size n equal to 120. If we simplify, minus 2.276. Can take positive value mod Z. And Z alpha 1.645 from level of significance. In step 5, the conclusion, we can compare these two values. 2.27 is greater than 1.64. Therefore, mod Z is greater than Z alpha. That means we are going to reject null hypothesis. What is the null hypothesis? P less than 0.25. Whatever the statement he passed, that statement also false statement or wrong statement. Coming to third problem, which is little bit different compared to the first two problems. The statement or description of the problem is experience has shown that 20% of manufacture are top quality. This is a general statement. Experience has shown that, observe that in the previous two problems, either it may be at least or either it may be less than or greater than, but here not given anything. Direct statement is given. Experience had shown that 20%. That means capital P directly 0.2, not greater than or less than. In one day production of 400 articles, sample size large sample, only 50 are top quality. So small p we can calculate 50 by 400, which is 0.125. Sample proportion is given. Test the hypothesis at 0.05 level. level of significance. Here we are going to get doubt which test is suitable for this problem, either test of hypothesis for single mean or this one. There is not at all a doubt, because the statement is given with sample proportion. Out of 400 articles, 50 are top quality. The mean value is not given, but proportion is given. Out of 400 articles, only 50 are top quality. That is the sample proportion statement. That's why this problem is suitable for test of hypothesis for single proportion. So capital P is 0.2, so capital Q is 0.8, because Q equal to 1 minus P. Now we are going to set up null hypothesis in step 1. Capital P is 0.2. Here we do not have any greater than or less than, because not given at least statement or fewer than statement or less than statement or greater than statement. So against to alternate null hypothesis, which is denoted by H1, P not equal to 0.2. This is two-tail test, not left tail or right tail test. So Z alpha value is 1.96, set alpha equal to 0.05. The test statistic Z equal to small p minus capital P by under root of PQ by N, and small p we calculated by using the formula P equal to X by N. 0.125 minus capital P 0.2 by 0.2 into 0.8 by 400 under root. So Z value we got it minus 3.75. Mod Z we can take positive, and Z alpha we have chosen from the Z distribution table. Now compare these two values in the step 4 conclusion. Mod Z is greater than Z alpha, so we are going to reject the null hypothesis. What we are going to reject is not equal to P equal to 0.2. Whatever the statement he has given, P equal to 0.2, that we are going to reject. Coming to the fourth problem, in a sample of 1,000 people in Karnataka, 1,000 people are there. Out of them, 540 people are rice eaters and the rest are wheat eaters. And you know that very well about rice and wheat difference. Here only the given statement sample proportion P equal to X by N, 540 by 1,000. Out of 1,000 students, exhaustive events are rice eaters. So this problem is suitable for test of hypothesis for single proportion. Can we assume that both rice and wheat are equally popular in the state at 1% level of significance? Alpha is given 1%. That means 0.01. Capital P, generally we can take 0.5 if the value is not given in the problem. In this problem, capital P value is not given like previous problems. So that's why capital P generally 0.5, capital Q is 0.5. Now the test of hypothesis procedure. First we are going to set up null hypothesis H0, capital P is 0.5. Alternative hypothesis H1, capital P not equal to 0.5. Which type of test? Two-tailed test, because not equal to is there, na? And alpha 1% level of significance. So this value we can choose from the table at 1% level of significance, a two-tailed test from the Z distribution table. That value is 2.58. Now in test statistics, Z equal to small p minus capital P by under root of PQ by N, where small p is 0.54 we have calculated, and capital P is 0.5, capital Q is 0.5. By sample size N is total population in the Karnataka is 1,000. If we calculate Z equal to 2.532, mod Z also 2.532. And Z alpha is 2.58. In the conclusion step 5, we can compare these two values. Mod Z is less than Z alpha, because 2.53, this is 2.58. So we are going to accept null hypothesis. That means P equal to 0.5 we can accept. That means the rice eaters and the wheat eaters are equally popular in the state of Karnataka. That statement we are going to accept. That means whatever the statement he passed, we are going to accept it, or which is true. Like this, we have to solve the problems on test of hypothesis for single proportion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.